Hello students, today we are going to talk about our next topic, that is relation between electric current and drift velocity. This is one of the very important topic for board examinations. In our last class, we have derived drift velocity is equal to E over m multiply tau. So this is what we have derived in our last class. So we have derived the relationship between the drift velocity and the electric field. Now we have to find the relationship between electric current and drift velocity. अपन last class क्या सीखा कि drift velocity करके ही electric current पैदा होता है. So for this, let us say that I have a conductor having length L. So this is a conductor having length L. And area of cross section is capital A. Area of cross section capital A. And we provided the potential difference by using a battery of potential V. So this applied potential difference will create an electric field in this conductor in this direction. Electric field will be created in this direction, and let us say that this conductor have small n number of electrons per unit volume. So I will write all these things, the symbols I will be using. So means I want to say that the free charge density is small n. So charge density means number of free electrons per unit volume. So due to this applied electric field, now I am saying that the electrons in this will drift in the opposite direction to the electric field with velocity Vd. So due to the drift of these electrons, the current is set up in this conductor. So let us say that that current is capital I. So this is what we want to talk about. So consider a conductor of length L, and area of cross section capital A. So please keep on making the notes. Let us say that the two ends are P and Q of the conductor. If capital V is the potential difference applied across the ends P and Q of the conductor, अगर हमने अप्लाई कर दिया आप इन्ना पोटेंशियल डिफरेंस अप्लाई कर देवांगे ये टर्मिनल के क्रॉस तो फिर की होएगा then an electric field capital E is generated or created, whatever it is, from P to Q, due to which the free electrons in the conductors drift from Q to P with the drift velocity V. This is what we have to write in the introduction part of this derivation. I hope that you have already made a note of this. You can take a screenshot of this and make a note. Now, so due to all these things, we said that due to this drift velocity, current I is introduced. So the drift of electrons leads to current from leads to current capital I from P to Q in the conductor. In the conductor. So this is also the part of the introduction. Let small n be the number of free electrons per unit volume of conductor. Then, because I want to find the current, so by basic definition, current I is equal to Q over P. So I want to know about the total charge that will flow through this conductor in the direction Q to P. Then the total number of charges. The total number of charges. I'm saying capital N. Since small is the charge density or the number of charges per unit volume, then N will be equal to small n multiply volume. Multiply volume. So, but N multiplies volume is area base multiply the length of the conductors. So, that will be A multiply L. So, this is the total number of charges that will be drifting from the end Q to P with the drift velocity Vd. Therefore, the total charge is equal to N multiply small e, if small e is the charge on each electron. So this is equal to N E A multiply L. So this is the total charge that will be drifting from Q to P due to electric field. So this is the total charge. Now we have to find the time. So time, since the electrons are drifting with velocity Vd, so the time to drift through distance L is equal to distance over speed. Distance over speed. तो टाइम का फॉर्मूला हो जाएगा ये डिस्टेंस ओवर स्पीड. So here the time t, distance is L and speed is Vd. Speed is V. So this is the time taken to drift of electrons from length Q to P. So T is equal to L over Vd. Now we have the total charge, also we have the time. So please make a note of this. Therefore, the current capital I due to drift of electrons is equal to total charge over time. So I is equal to total charge is NEAL over time is L over VD. So this is equal to NEAL multiply VD over L. So this L will get cancelled with this L. So this is equal to NEA VD. So this is the relationship between the drift velocity and the current. So this implies I is directly proportional to the drift velocity. So more the drift velocity will be there, more will be the current. Similarly, we can find the relationship between the electric field and the between the electric current and applied electric field. We have Vd is equal to EE over M multiplied tau, so that can also be used. Since Vd is equal to EE over M multiplied tau, therefore I can also be written in terms of applied electric field. So that is equal to NEA over M, NEA multiply EE over M multiply tau. So this will be equal to NE square A E over M multiply tau. So this is also the relationship between the current and the applied electric field. So these two parts are very important for your Punjab board examinations. You can make a note of all these things. With this, we close for today. Thank you. Have a nice day.